Okay, so hello everyone. In this video, we'll be solving the question number 3312, which is sorted GCD pair queries. It is marked hard. The question is very easy to understand, but the main bottleneck which makes this question a hard level question are its constraints. So let's first understand the question and then derive one approach that moves along with the constraint. Okay, so let's start. Okay, so we are given an integer array nums of length n and an integer array queries. So we are given two parameters. One is integer array nums and the other is queries. Suppose GCD pairs denote an array obtained by calculating GCD. GCD is greatest common divisor or HCF, which is highest common factor of all possible pairs of nums of I, nums of j, where 0 I and j lie in the range of 0 and n, and then sort this value in ascending order. Okay, so GCD pair is one of the array which is formed by getting GCD of all the possible pairs, like all of the possible pairs you can even think of a particular array, and then we have to sort it in an ascending order. Okay. For each query of I, we need to find the element at index query of I in GCD pair. Okay, so the array which is to be formed here, in that we need to find the element at index query of I. And what is the query of I? Which is an element present in the queries at ith index. Okay, we need to return an integer array answer where answer of I is the value at GCD pairs queries of I for each query. Okay, so what we have understood is that we are given two parameters, one is nums and one is queries. So what we have to do first is we need to obtain all the GCDs of all possible pairs. So for a given array nums of length n, for all the pairs which could be possibly created, we need to find the GCDs of all of them. And then of the formed array, we need to sort it in ascending order. And for in the queries, we will be given one element and we need to find the GCD present at that index in the GCD pair. And we need to store that answers in a particular array and we need to return that array. It looks very simple. Let's take one example. The example provided in the Leetcode itself. 4, 4, 2, 1. Okay. So what all possible pairs could be formed, which is 4 and 4, 4 and 2, 4 and 1. We are making pairs by considering this 4 present at index 0. Later, we will form by considering this 4 present at index 1, which is 4, and we cannot form this for 1 second because we have considered 0 and 1. We can't consider 1 and 0 as well because it will be the same thing. So 4 and 2, even though it was formed here, it was by this 4 and this 2. Now this 4 and 2 which is created, it is by this 4 and this 2. And 4, 1 and 2, 1. These are all the possible pairs. Let's calculate GCD of each, which is 4, which is 2, which is 1, which is 2, which is 1, which is 1. So the GCDs are this 4, 2, 1 to 1. Next step is to sort them, which will be 1, 1, 1, 2, 2, 4, and we are given queries, which is 5, 3, 1, 0. So now what it asks is find the element at index queries of I in GCD pair. So queries of 0 will be 5, and at index 5 we need to find the element. So here in this case it will be 4. For at index 3 we need to check here, which is 2. At index 1 we need to check here, which is 1. For index 0 we need to check here, which is 1. So this is our answer. We just need to return this. We can do this pretty easy. Like what we can do is we will iterate I from 0 to n, and we can iterate j from I plus 1 to n, and then for all possible pairs we will calculate GCD, push it in an array, sort the array, and then we will get GCD pair of queries. Is simple, but the thing which restricting us is this: we are having a nested loop which will be O of n square, and here the possible value of n could be 10 power 5. So taking considerations 10 power 5, it will be 10 power 5 square, which is 10 power 5 into 10 power 5, which is 10 power 10. And as per the normal IDs or like coding platforms, 10 power 8 is 1 second, and it is considered as TLE. So we are 100 seconds, like 10 power 8 is 1 second. So 100 into 10 power 8, we are taking 100 seconds, which is far way beyond TLE. So we have now only two options, that either we should go for n log n or log n or constant space. We have three options, my bad. So now what should we guys do? Log of n seems as of now pretty, what you can say, doesn't fit in. Let's try for n log n. Or what we could do is use this given fact that nums of I lies in the range of 5 into 10 power 4 to 1, because this could give us a little relaxation. So yeah, a bit better slight of approach is better than getting an TLE. So what we can do is take the same example here. Hmm. 4, 4, 2, 1. If we want to find GCD, the main thing are the factors. We want all the factors that could contribute to the elements provided here. But since the maximum possible number is 5 into 10 power 4, why not find all the factors and all the multiples that lie within this range? That is the range from 1 to 5000. Like suppose the factors will be 1 to 50,000, and we will try to find their multiples which lie in the range of 50,000. Okay, so for this case, let's move it here. We will get 1. Its multiples are 1, 2, 3, 4, 5 till 50,000. Then 2, 2, 4, 6, 8 till 50,000. 3, let's add here 6 as well so that it could be like solve many doubts and be generalized. 3, 6, 9, 12 and many more. 4, and likewise you will do that. But don't you think that if our maximum element here is 6, like finding out that 3 has multiples 9, 12, 15 and many more will be any beneficial, because knowing the fact that 12 is a multiple of 3, 9 is a multiple of 3, it will not contribute here because it is an unnecessary fact. So what we will do is we will restrict our finding multiples till this maximum element. Here the maximum element is 6, so we will go till 6. Here 8 is beyond 6, so we'll skip it. 9 and 12 is also beyond 6, so we will skip it. Here we have 4, here 5, 6. Now we have found out that 1 has these multiples, 2 has these multiples, 3 has these multiples. So is this even helpful? Is this helpful? We have found that 1 has a multiple 3. Okay. 3 has a multiple 3. But it is nowhere to be useful here. This factor is helpful, but knowing that 3 is a multiple of someone is not helpful. Are you getting the point? That we have these many factors. This is a list of factors, and the column is the factor list, and the rows are the what you say multiple list. So here this 3 is unnecessary. Here this 3 is unnecessary. Here this 5 is unnecessary. Okay, so what we have found out that uh, find multiples, but one condition, till max element until and those only which are part of nums. Okay, so as of now, let's first implement this much. Let's give this one a box. A white color will work so that we can differentiate. Okay. Uh, how we will do it? Factors list is from also 1 till 6, because if the maximum number is 6, finding out the multiples of 7 is also not useful, because 7 cannot be a GCD of any of these possible numbers array, right? Suppose 7. We have found that 7. Okay, just for now, we have found that 7 is a multiple of 7. But can this 7 divide any of these? It is greater than the maximum element. So how will it? So what we have restricted is find multiples till max element, and those the part of elements, and factors must be also till max element. Okay, we need to consider this sequence. So let's create one program to do this. For int I equals to 1, I less than equals to max le I plus plus. For int j equals to I star 2, j less than equals to max le j plus equals to I. So this is a method to find multiples of I. Suppose I is 5. Let's start from 1 because so if j equals to 1, we will get 5. Then j will become, now increment will happen from here. What many guys do mistake is that seeing this, they increment 1 and here they multiply 5 with 1 or anything like that. So after this is just the starting point, and here we are incrementing the number the j with the I itself, so that it is taking leaps by the factors. So first it was 5, now j will become 5 plus 5, which will equals to 10. Later j will become 10 plus 5, which is 15. So as a result we are getting the what you can say multiples. Okay, now that we have found the multiples, our main task is to find GCD. But for finding GCD, what is the main one of the key requirement are the factors. But what we can do is now we know that 1 is present here and 1 is a factor of 1. Okay, so 1 is useful for a one element. 2 is present here, so 2 is also 1 is useful or a considerable factor for these two as well. 3 is not present here, so we will skip this as of now. Let's remove it only. Here is a 4. 1 is considerable for this 4 as well. But there is one more 4. So we need to consider this 1 as a factor for this 4 as well, right? Because what we are doing is find all possible pairs. If we consider this possible 4, we need to consider this 4 as well. So we will also make sure that this one is checked for this 4 as well. Okay, there is no 5, no need, let's keep it. And 6, there is 1 6, so this 6 will be considered. So what we will do is we will keep a track of for how many numbers of that particular nums this particular factor is a possible candidate for being the GCD or HCF. Here 1, 2, 4, 4, 6. So it is a possible candidate for 5 numbers. Here is 1, 2. 2 is a possible candidate for 2. This 4 is here, but we need to consider this 4 as well, right? So this 4 is also to be considered 6, 6. So 2 is a possible candidate for 4 elements. Likewise, 6 is for 1, 4 will be for 2, 5 does not contribute currently, so it will be for 0, 6 will be for 1. Okay, so you guys have found out that we also need to find out that what how many this can be possible factor. Since we are not iterating this array, this for loop has nothing to do with this array. We are finding all the factors, and for all factors we are finding their multiples. So how will we keep a track that it is this one is useful for this many fours and the 3 which we will found is not at all helpful here. So to keep a track of how many to be useful, our first intuition might be a map. And here let's create one map. Hmm, hmm. A frequency map in which we will store which element is how many times. 1 is 1 time, 2 is also 1 time, 4 is 2 times, and 6 is 1 times. Okay, so now we found out here that j is multiple of I. I is to be considered for how many ele elements. So we also need to keep a track like here that this one is useful for 5 elements, this 2 is useful for 4 elements, this 3 is useful for 1 element. So we will create one more map. Uh, hmm, okay, which will have key as factor and value as count of useful multiples. We can say that these many multiples are useful, right? You guys can give a name as per you. And let's give this map a name as how should we name this? Okay, valid mul valid multiples. Okay. Okay, so for this valid multiples of I will be incremented by frequency map of j. Here for 1, here for 1, when we found out that here j is 4, we also check that here 4 is to be considered 2 times. So frequency of 4 is 2. So here in this value 2 will be added. Okay, is this much understandable? I hope you guys are understanding. If you guys have any doubt or not able to understand, please do let me know. I'll be happy to provide a valid explanation. Yeah, just a short clip. Now, now we have found out that what we have found out. Let's make a quick checklist. This vector has these multiples. We have also ensured that only useful ones are stored, and also we have considered the frequency of that multi. Sorry. Now what to do? We need to find pairs. Like we need to calculate the GCD of pairs of each possible ing. So as of now, so we have just found out that these are the possible GCDs. We haven't even found out that these are the GCDs of this particular pairs. So from the information which we have collected, let's do one thing. From the information that we have collected, we will try to find out that this factor is possible GCD of how many pairs. Here we found out that as divisors, that I is to be considered as divisor for how many elements. Now we want to find out that this factor is possible GCD of how many pairs. Now here we have found out that 1 is a possible contributor to these five pairs. Elements. So if we find out five pairs, not five pairs, the number of pairs which can be formed out of these five elements, we can say that one can be a possible GCD for these many pairs formed by the elements it divides from the nums. These are the number of variables present in that nums which are divisible by 1. And here is the list. So why don't we find out the number of pairs for which this factor can be considered a possible GCD? A possible GCD. So if we are given 5 elements, the number of pairs is 5 seat. It is a permutation and combination thing, in which if we want to find how many two numbers can be taken from n elements, it is generally denoted by nc2, which is nothing but n star n minus 1 whole divided by 2. So here we have 1, here we have 5. Why don't we find out the number of pairs just by applying the NC2 formula over this, which here is the value part, like the count of useful multiples. So for auto it equals to what we have named here, is, what is the name? Valid multiples. Valid multiples. It is a very big name. I think should shorten it. It not equal to dot end. I'll make a video in which I'll cover the STL part, in which how we should create a map, how to iterate a map, how to access the map's iterator's value, iterator's key. Now, just for now, understand that it.first is key and star it dot second is value. Okay. Now what we have currently here, we have the list of possible elements. Okay. So now we will modify here only star it dot second. Let's copy it, equals to star minus 1 here, okay, by 2. So you can consider that this is n, this is n minus 1. We multiply them and then we divide by 2. So what we have done is replaced valid multiples with possible pairs. Okay. Now we have found out that for this one, we can form 5C2, which is 5 into 4, 10 pairs. 5C2 is 10 pairs. For these two, we have found out that 4C2, which is we can form 4 into 3 by 2, 6 pairs. Okay. So now we have transformed this frequency of valid multiples to the frequency of valid pairs. Okay. Let's add one note about here. Okay. This is okay. Okay. Now what we have found is that for each possible factor, these are the possible pairs for which it can be a GCD. We are not sure that this factor is GCD of this pair. We just know that this factor can be possible GCD for this many pairs. So how will we find out that this is a possible, what you can say, GCD for exactly this many pairs? Okay, so for suppose, okay, we know that we are given that phi is a possible GCD of phi, 10, this pair, 10 and 30, this pair. Okay, and its count is 2. And we are also given that 10 is a possible, what do we say, GCD of 10 and 30, which is the count of 1. And we are also given that 30, but it is not able to form any pair. So its count is 0. So what we will do, for 30, we will check 30 is a possible GCD of how many? Currently it is 0. And if there are any, so is there any multiple of it like 30, 60 or 90 which could take its place? Like let's understand with 5, example of 5. We know that 5 is a possible GCD for these two pairs. But we can see that for this pair, a 10 is the correct answer because 10 is also a GCD for it. So how do we get that 5 is a valid GCD candidate for this many, but a valid GCD for only one? So if we want to find the number of pairs for which a 5 is a GCD, we will check that are there any of its multiples who can ruin their party. Here there are two multiples of 5. It is 30 and 10. 10 is ruining his party in just 1. So we cancel it and subtract 1. Okay. Now for 30. 30 is not ruining its party. So we subtract 0. So what we have decided is that 5 initially had two possibles, but 10 came and took away one pair. 30 decided to came, but he was not able to form pair. So 5 is a valid GCD of only 1. Now here 10 has 1. He thinks that who are my possible candidates, that who can take away my pairs from me. So he knows that okay, 30 is the guy who is present here. But he also knows that 30 is not able to form any pairs. As a result, he is not a candidate for any particular pair. So he decided, okay, my from my one pair, nothing is taken away. So he is a GCD of one pair. I hope you guys are understanding. Okay, so for 30, there is no one to steal his 0 pairs. So 0 will remain 0. So we have found out that 5 has one pair for which it can call himself as GCD, 10 has one pairs and 30 has 0 pairs. So what we need to do is, okay, find the all competitors pair, and competitors are no one but his multiples only, which are acting as factors for others. Here for 5, his competitors are 10 and 30, which like who are its multiples only, right? If his what you can say 15 is also one of the competitor, but 15 is also forming no group. Like he is not dividing 5, no 10, but he is able to form like divide 30, but he is not able to group him into some another pair. Like there is no another 30 as well. There is no another distinct number as well which is a multiple of 30. So as a result, this will also become 0 using the formula n minus 1 by 2. Okay, so we will find all the competitor pair find all the competitor pair. Competitors are no one but the multiples. Here 10, 15 and 30 are its multiples, which are acting as factors for other. Here 10 is acting as a factor for 10 and 30. 15 is acting as a factor for 30. 30 is a factor for 30, but he is not able to form a what you can say a pair with anyone. So how will we do this? Is you might have even found out that if we want to find for 5, we need to have the answer for 10s and 15s and 30s predefined. So if we want to find for 30, the number of prerequisites will be different. If we want to find for 15, we need for 30. If we want for 10, we will need for 15 and 30. So why don't we start from the max element, like from the upper limit? So for int I equals to max LE, I greater than equal to 1, because 1 is also a possible candidate for someone. Let it however be 1, but 1 is a possible candidate. For int j equals, now j is the competitors. J are the competitors of this I. J equals to I start to. J cannot start with I, because if I will become competitor of myself in this case, not philosophical, if in this case I'll subtract all of mine. Here phi has 2 pairs, and if phi subtracts the number of pairs from itself, 2 will be subtracted from 2, and as a result it will become 0. What is the map here? Map here is the varied multiples. For phi, we have seen that we subtracted the number of pairs for which 10 was taking away its pairs. 10 was taking away these pairs. Okay. So now we have found out that which factor is a GCD for how many. Not phi is, we will find out that phi is a GCD of one pair. We will not find out that it is a GCD of this phi and 2. And we do not want to even find out that 1 is a GCD of phi and 10. Phi is a GCD of phi and 10. We just want to find out how many pairs are there for which phi is a GCD. Okay, so we had done, oh yeah, here it is. So at the end, after this step, what we would have find out is this. Sorry. One is a GCD of 3 elements, 3 pairs, sorry. 2 is GCD of 2. 3 is GCD of 0. 4 is GCD of only 1. Okay. Now what we have to do? Now what should we do? We just found out that 1 is GCD of 3 pairs. 2 is GCD of 2 pairs. 3 is GCD of 0 and 4 is GCD of 4, only 1 pair. But we need to form an array. Here we are told that GCD pairs is an array obtained by calculating GCD of all possible pairs. And for queries I, we need to find element at index this in GCD pairs. So you might have noticed that if there were how many? Four elements in this. Sorry, three. Okay, did we consider? Okay, there were four elements in these nonce. And how many pairs did we get? 1, 2, 3, 4, 5, 6. Which means that if this is the size, n is the size, number of pairs will be nc2, which is n minus 1 whole divided by 2. So if the n is 10 power 5, the formation of a array, like if someone wants that, okay, now I have got this, now I will form an array 1, 1, 1, 2, 2, and 4. Here we need to push back 6 elements. So it is okay. But for 10 power 5, just do this operation. We need to push back this many number of elements in an array. So even that will become a TLE. So what I should do is that we would keep a track. What track? That here we have 1 as one of the GCDs, 2 as one of the 3, and 4. How many are of them? 1 is the GCD of 3. 2 is GCD of 2 pairs. 3 is GCD of 0. 4 is GCD of 1. So why don't we just think like till 1, how many pairs are encountered whose GCD is less than or equal to 1? Till 1, we have as of now 3 pairs only whose GCD is less than or equal to 1. Now we go to 2. Till 2, how many pairs are encountered whose GCD is less than or equal to 2? So equals to 2, we have 2 pairs, and less than is of 1 and no other. So 2 plus 3, 5. For 3, how many pairs have been encountered whose GCD is less than equals to 3? Okay, so for 3 we have 0, for 2 we have 2, and 3 we have, for 1 we have 3. So 3 plus 2 plus 5, 3 plus 2 plus 0 is 5. And plus 4, all the previous sum is 5. And for here, 1 itself of 4. So it should be 6. So you can say that for 2, the sum till previous and plus itself. For 4, the sum till previous and then sum of itself. This is the, okay, we got it. There are 6 elements in the array, 6 also. Now someone tells me that query of I is 4. So I need to find the answer at GCD pair 4. But we do not have an array. We have a prefix array like this. So think like till this index. Till this index, only 3 pairs were encountered. Okay, and the GCD was 1. So definitely for the fourth one, GCD cannot be 1, because if its GCD was to be 1, here it should be 4. Okay, and when we moved from 1 to 2, we saw that the frequency increased from 3 to 5. It means that previously there were 3 pairs whose GCD was less than equal to 1, but now it changed to 5. It means there were addition of 2 pairs whose GCD was 2. So we can say that for the pair 4 and 5, the GCD is 2. So likewise, if we were to find 6 at 6, we can say that till in the GCD 3, there were 5 pairs whose what you can say GCD is less than equal to 3. But as we shifted to 4, the count increased. It means that the sixth pair was the one with GCD as 6. So what we are doing is we are finding upper bound. Okay, so this is the approach. What we do is first find a frequency map where it is. Okay, first we find the frequency map, we find the maximum element, we also then find all the multiples and from which how many multiples are useful, if it is useful, what is its frequency. Then from the frequency we have found, we try to find out how many pairs can be formed so that that factor is a valid candidate GCD for how many pairs. And then we try to find out the count of pairs for which a particular factor is a definite GCD. And from then we try to create a prefix array in which we keep a count of how many pairs have GCD less than or equal to the current GCD. Okay, and for the query, we find out the upper bound, which is implemented using binary search. Okay, let's then do it. And I will explain the time complexity as well. Okay, let's erase this. Okay, what we need to do is find max ali and rec map. Okay, since the given nums is integer, a max element would also be an integer. As of now, let it be nums of I. And a frequency map is frec map. Okay, since here will be the key, and what is the key? Key will be the values present in this nums. It is an integer, so it will be integer. And what could be the maximum frequency? If suppose all the numbers are 1, suppose all numbers are 1, and the nums length is 10 power 5, it can be accumulated in this integer. So value and key both will be integer. Okay, so for auto, this is called a for each loop. We will iterate it over nums. We will update the frequency of val, and also we will update the max. Okay, now we have found out that this is a frequency and this is the maximum element. Okay, where we are. Okay, we have found out that this is the frequency and this is the maximum element. Now what we will do is try to find out all the required and suitable multiples for the factors 1 to max element. Okay, we will start from 1. we will go to max LE, because going beyond max LE will not be useful, because those factors will not be providing any contribution in finding GCD. Okay, for int j equals to I, because we need to consider if we are starting a table of 2, 2 ones are 2, so 2 is also multiple of 2, right? And if we are doing a table of 2, 2 ones are 2, and then we do the addition of 2 itself, 2 plus 2, 4, 4 plus 2, 6. Now, what we need a map. Uh, okay, this key will be integer. How many, if suppose 1 is the table, one's table is going, and maximum element is 50,000. We can keep a track of 50,000, that 50,000 numbers are multiples of 1, so it can be stored in this also. Number of mul number of mul of I plus plus. Now that we have found a number of multiples, no, what, so my bad, here, what we did was we found out that 4 is a multiple of 1, but we also made sure that both the 4s are included. So what we did was valid multiples I plus equals to frequency of that element. So frequency of j, this is the multiple of I, right? Now that we have find out multiples, now what we want is number of pairs. Now is the main thing. If there are 50,000 elements, all are 1, then we can say that 50,000 multiplied by 49,999 and then divide by 2. This many uh, pairs can be formed for 1. So it will be a long. So I hope you guys are getting me. So let's create map integer. Here the key is always less than or equal to 50,000. So it will be integer, and then we will store value in long just for this number of pairs. Okay, now this is how we iterate a map using iterator. I'll surely discuss this in my STL playlist. As of now, let's do it this way. What is that? If we want to access the key value of a map, it is done through this, and the key value is done using this. Okay. So number of pairs, who's this one? Suppose 10 has had 20 multiples. So for 10, we will store it here, that number of pairs for 10. 10 is the key, and we get the key through this is star it dot second. 20 is the value. 20 is the n. So we get the value to star it dot second. So we have done the first of n. Then this is n minus 1. You getting it? And then divided by 2. Okay. Now we have found out the number of pairs for which it is a potential candidate. Yep, right. Okay. Now get the count valid GCD pairs. Now what we want is, we'll start from back as we have discussed. Where it is? Here it is. If we start from 5, we need to calculate for 10, then 15, 30, and then come backwards and then store it in 5. So why not let's start from 30 itself. That is here the max element itself. That is, we start from max element till 1, because 1 can be also a possible GCD for someone. Now we'll do for its, what you can say, multiples. We do not start from the number itself. J equals to I star 2. We do not start from the number itself. J less than equals to max LE and J plus equals to I. My bad. For int J equals, okay, multiples are checked. Now the number of pairs of I, this equals to of I minus those of his competitors. Who are his competitors? Its multiples. Okay, so now we have found out that this I has this many GCDs. Now what we want is prefix array. 0 cannot be a GCD of anyone. So we want to start from 1 till 4. 4 can be a possible, like a maximum element can be a GCD of someone. So what should be the size of this prefix array? 0, because we will store it index wise. 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4. So the size will be 5. So maximum element plus 1. And let's as of now just assign 0 to 1. Now for int I equals to 1, as we have done, we start from 1 and move till the max element. Okay. And what we do is, for a particular 3, for a here 4, till previous it was 5, and then we add 1. So prefix till I minus 1, and then add count of pairs for that element. This was the previous part, and then for itself. Where is it itself? Here, number of pairs. Now we have found, now we will iterate the queries. for each loop once again. We can use uh, like for loop, like int I equals to 0, but you should try this as well because we get the direct element itself. We do not need to do nums of I. We will declare one answer array. Ans no. We want to find the upper bound of that query of I. Here in this case it is Q in rest. Okay, so if you guys don't know, here this is how we find upper bound, but we don't. By finding upper bound, what we do is then get the index. If GCD at index 4, we found out that it lies up after 3 and before 5. So what we receive is this 5, but we do not want 5, we want 2. So what we do is subtract the beginning. Okay, so uh, let, hmm, this is how we write uh, upper bound. From this, as we have discussed, we will get 5, but we don't want 1, we want 2. So what we will subtract is and return answer. Let's run this and hope that this works. I mean, there are no, what you say, any compilation error. Okay, here is an error. Okay, we are not pushing back in the answer. Rest, I hope is correct. Otherwise, I'll edit few minutes. Okay, 222, 122, 3211. Mm-hmm. We have found multiple factor j equals to I plus equals to still incorrect. 111, 2211. Okay, okay, so I'll just pause and return. Okay, so I guess I found out where is the error. Here it was the bracket issue. Let's check it. There is no faking. I hope submission also works. Assign integer overflow. Okay. Hmm. If you don't understand what one should do is not everything into long and then use this test case and then try. Okay, but one should not. For your information, Max doesn't work with the long. Hmm, I guess it should not have gone up long. Okay. Yep, it was a very long question, but I guess this is what makes this question harder. But I hope you guys understood it. If you are not able to understand, do let me know. Yep. For the time complexity, what is happening here is we are iterating here. So this is O of n. This is iterating the entire array, and here it is O of n because we are iterating entire array. Here, what is happening is we are uh, incrementing it. So here it will be not O of n, but a little less than that, and uh, here it is okay. This is also O of n. This entire question is not being solved in O of n. Okay, yep. Here it is O of n. Here it will be O of n by 2 plus O of n by 3, and like that. I guess this also turns out to be entire thing. Entire thing will turn out to be O of n log n. But if it turns out to be O of n square, it will not be like a classic O of n square. But due to all these modifications, many changes will be made. Hope this helps, but I'll comment out this thing because as of now, here this is the case, but of n by 1 also happens. This upper bound is of log n, and this is of n. So this entire function is of n log n. This is of n, the creation of error of f. This is also the same as for finding multiples. uh, n into n by 2 plus n by 3 plus n by 4, like that. This is also of n. Only this one is the thing that I'll surely let you guys know. If you have any doubt, do let me know. Thank you.